So in the last chapter, you learnt about functions, their properties and inverse of a function. Now in this chapter, you will learn about inverse of trigonometric function. Now before that, let's recapitulate basics of trigonometric function. Remember from your previous classes, if we have a right angle triangle, then the side just opposite to the right angle is called as the hypotenuse, and the side just opposite to the angle is called as the perpendicular or the opposite side, and the other side is called as the base or the adjacent side. And the ratios of various trigonometric functions are defined as the sine of theta is equal to perpendicular upon hypotenuse, or we can write the opposite side upon hypotenuse, and the value of cos theta, also called as cosine, is equal to base upon hypotenuse, or we can write adjacent side upon hypotenuse, and the value of tangent theta is equal to perpendicular upon base, or you can also write opposite side upon adjacent side. And also cosecant theta is the reciprocal of sine theta, secant theta is the reciprocal of cosine theta, and cot theta is the reciprocal of tan theta. So let's first study the properties of sine function, and for that we shall draw a graph of sine function, and on the graph we take angles on the x-axis, and on the y-axis we have the corresponding values of sine theta. So here you can see on the x-axis we have the angle 0, half pi, 2 pi, and on the negative x-axis we have minus half pi, minus pi, and so on. Also you can see the value of sine function always lies between -1 and 1. And also remember, the sine function is a periodic function and it repeats at an interval of 2 pi. And now we come back to our main objective, which is to find the inverse of given function. And now to find the inverse of sine function, first of all we shall check whether this is invertible. Now the given function will be invertible if it is injective as well as surjective. Now let's first check whether it is injective or one-to-one function. Now here you can see from the graph there are number of angles on the x-axis at which the value of sine theta is same. Like here you can see sine 0 is equal to 0, but sine pi is also equal to 0, and sine minus pi is also equal to 0. Also you can see sine half pi is equal to 1, but sine minus 3 pi by 2 is also equal to 1. So that means the sine function is not a one-to-one function. And now let's check whether it is an onto function. Now here you can see the range of the given function is from -1 to 1, but the y-axis contains all the real numbers. So you can say the sine function is not defined if the value of sine theta is greater than 1 or less than -1, or in other words, the range of the sine function is not equal to the codomain of the sine function. So that means the given function is also not an onto function. So the sine function is neither one-to-one nor onto function. So that means this is not a bijection, so it is not invertible. So the function sine theta doesn't have an inverse function in its complete domain and range. But what if we restrict the domain to the interval minus half pi to half pi and the codomain to minus 1 to 1? Now in this interval, you can see there are no two angles on the x-axis which have the same value on y-axis. So that means in the interval minus half pi to half pi, the given function is 1 to 1 function. Also here you can see the range minus 1 to 1 is equal to the codomain, which is again minus 1 to 1. So the function sin x is both injective and surjective in the interval minus half pi to half pi and in the range minus 1 to 1. So that means in this range it is also invertible. Just like minus half pi to half pi interval, there are also other intervals like minus 3 pi by 2 to minus half pi and half pi to 3 pi by 2 and so on. In general, you will find the sine function is a bijection in the interval n pi minus half pi to the interval n pi plus half pi where n belongs to integers. And now as the sine function is invertible for the given domains, let's find its inverse. In the chapter Function and Relation, you have already learned that if f is a function from a to b given by f of x is equal to y, and if it is invertible, then its inverse is the function g from b to a given by g of y is equal to x and is called as inverse of the function f, and its inverse is denoted by g inverse. And also the domain of inverse function g is equal to the range of the function f, and the range of inverse function g is equal to the domain of the function f. And now in case of a sine function, the function is defined as the function f in the domain minus half pi to half pi to the codomain minus 1 to 1 such that f of theta is equal to sine theta. And in this interval, its inverse is denoted by sine inverse, and domain of the sine inverse is equal to minus 1 to 1, and its range is equal to minus half pi to half pi, and it is defined as sine inverse x is equal to theta if and only sine theta is equal to x. Now let's draw the graph of sine inverse function. And now to draw the graph of sine inverse x, we interchange x and y axis. And graph so obtained can be seen on the screen. Here on the x-axis we have got the values which lie between minus 1 and 1, and on the y-axis we have got the values of angles. And also from the graph of sine function, you can see apart from the interval minus half pi to half pi, there are also the other intervals like minus 3 pi by 2 to minus half pi and half pi to 3 pi by 2 and so on, in which the function sin x is a bijection. So now you have seen for the sine function, if the domain of the sine function is n pi minus half pi to n pi plus half pi, where n belongs to integer, then it is an invertible function. and for each value of n, we get a separate branch of sine function, and also the main branch of the sine function, which is sine inverse from -1 to 1 to minus half pi to half pi, is called as the principal branch of the sine function.